All right, this is the video finishing up the 8.2 set of notes about the odds. So it says when the probability of an event is known, it is often customary, especially in gaming situations, to speak of your odds for, which means in favor of winning, or the odds against, which means you're going to be listing what the losing chance is first. So it says if you roll a fair die once, then the odds for rolling a 2 are 1 to 5 because there is 1 2 on the die and 5 non-2s. So we sometimes write that as 1 colon 5. That's a nice way to write that, or 1 2 5. And the odds against rolling a 2 means you list the unfavorable situation first. So there's 5 non-2s on your dice, 2 1 2 on your dice. So that's 5 to 1. If probability P of E is the probability of the event E, then the odds are listed in the following way. So if you know the probability of your event, then you would list the probability for the event on top over the probability of the complement. Because remember, essentially you're either breaking things into favorable and non-favorable. So either what you want or everything else in the universe. Odds against would be the non-favorable or the complement on top over the favorable. Now, usually I don't like to write my odds in fraction form because then it gets confusing with probability. So I like to prefer either writing 1 to 5 or 1 colon 5. So odds have a natural implication regarding fair games. In the example above, if you bet $1 on rolling a 2, then the house pays you $5 and returns your $1 bet. If you roll a 2, otherwise, you would lose the $1 bet. So you don't get any money, you just lose your bet. You don't get any extra money. So if the odds for E are A to B, then the house pays you a B dollar amount. So so notice this is in favor. This is the non-favorable. So we want to make sure we understand this. So in other words, think that of win to lose, right? So if you're doing odds for and you have your A to B, then if you win, the house has to pay you the payout for the non-favorable amount, whatever that is. So if this is 1 to 5, they're going to pay you $5 and they return your, say it was 1 to 5, they're going to return your $1 bet. If E occurs, now, otherwise you would lose your $1 bet. Okay, so let's talk about this. Compute the odds for and odds against obtaining a number greater than 4 in a single roll of a die. So remember, your die is your sample space. You have 1, 2, 3, 4, 5, or 6 on the die. If we're doing odds for, what we're going to be listing is, and I like to do the colon, this is actually what we want, which is a number greater than 4. So this scenario is anything else. So that would be less than or equal to 4, because notice they didn't say equal to on the 4. So there are only 2 numbers on the die that are greater than 4. So this would be a 2. There are 4 numbers on the die that are not greater than 4. So that would be the less than or equal to 4. Now we usually reduce our odds down. So this is a 1 to 2 odds for. So there's one for every 1 favorable account, there's 2 non-favorable is essentially the reduced amount. Now, if we want to do the odds against for this same specific thing, all you have to do is change the order of how you wrote your ratio. So this would be 4 to 2. So unfavorable listings first, favorable listings second. So losses first, wins second. That's essentially all you're doing. So that's a 2 to 1. Notice it says if you bet $1 on rolling a number greater than 4, so on winning, what should the house pay you in order to keep the game fair? Well, they're going to have to pay you $2 because that's the amount, the B, the A to B, that would be the amount against you. Okay. Plus they would need to return, you want to sometimes make a little side note, return your $1 bet. Okay. All right, what are the odds of rolling a sum of 6 in a single roll of 2 fair dice? Okay, so this is remember we had this broke down in class, so I'm going to really quickly just do it. We had the dice where you roll 1 1, 1 2, a 1 3, a 1 4, because remember we're rolling 2 dice, a 1 5, and a 1 6. We have 2 first, so 2 1, 2 2, 2 3, 2 4. 2 5, 2 6. Then we get a 3 on the first die. We're just running through the 1 through 6 again. Notice once you've made this a couple times, it's not too bad. 3 4, 3 5, 3 6. Then we have 4-1, 4-2, 4-3, 4-4, 4-5, 4-6. We got 2 more rows to do. 5-1, 5-2, 5-3, 5-4, 5-5, 5-6, and then 6-1, 6-2, 6-3, 6, 6-4, 6-5, and 6-6. So remember, there are 36 outcomes when you roll 2 die and you look at both numbers that come up. And we remember in this class, we're assuming that these are essentially distinguishable from each other. Like we have different colored die, or we know one die, you know, is rolled first and the other one's rolled second. We know how to tell the difference between them. So we're looking for the odds for, so this is in favor of rolling a sum of 6. So when I look at our list right here, and I'm looking for things that add to 6, remember I said go down the first column, see if you find anything. So this 5-1, then there's usually a diagonal going up from there, from this bottom to top, that adds to that same amount. So notice 4 and 2 add to 6, 3 and 3, 2 and 4, 1 and 5. So the number of favorable outcomes, so odds for, so we put our favorable, which means they sum to 6, and these other ones are going to not sum to 6. Okay, so we have 1, 2, 3, 4, 5 out of the 36 outcomes that are going to sum to 6. That means if you subtract 5 from 36, that'll tell you how many don't sum to 6. So that's going to be 31. So this is a 5 to 31 odds in favor of rolling a sum of 6. Now, if you bet $1 that a sum of 6 will turn up, what should the house pay if the sum of 6 turns up for the game to be fair? So for this one, it's a little different because you have your $1 bet, which is not what our odds for are listed in. So let's talk about how we're going to figure this part out. Now, if you, I believe in the homework, they don't give you any of the specific types where you don't have a nicely even, or it doesn't turn out to be a 1 in the front. But essentially what we do to fix this is, and I believe they have you type all your odds in as fractions, which makes me angry because then people think it's probability. But anyways, on the MyMathLab, if you had this typed in for your odds for, okay, so you have it typed in and it's fraction form, and they ask you about the bet information, which we're about to do in a second. If you want to figure out the one, what would it be if there was a 1 in front? You just have to divide both top and bottom by whatever that value is in that first spot for that in 4. So I divided that and I got 1 over 6.2. And again, that's not typically how we would leave a fraction. This is just for the bet part. So this would be remember, this is like an A to a B. And if they want you to, if you bet your $1 that the sum of 6 will turn up, so you're going in favor of that, then if the house says, oh, it happened, what do they have to pay you to be fair? They'd have to pay you $6.20. Again, the ones on the MyMathLab that I tried to regenerate that homework a few different times, and I always got one that was more like this first one where you get a 1 in the first spot anyways, which makes it a nice whole number for the bet. But that's how you would handle that. Okay, so let's look at this last page of examples. This is our card deck again. It says a single card is drawn from the standard 52 card deck. Calculate the probability first as a fraction. So we're going to do probability of something, and then we're going to do the odds for, okay? And that is selecting a black ace. And we're going to do the odds for selecting a black ace. Again, I like to start off with my odds in that colon format. But before we do that, let's do the probability. So a black ace, there are 2 of those out of the 52 cards. Because remember, to do probability, you say how many are there that I want out of how many total are there. If we reduce that, that's going to be 1 over 26. So you've got a 1 in 26 chance of getting a black ace. When you do the odds, it's a little different. You have to tell me how many black aces there are. You're doing the essential, what is E, and then you tell me the complement, not black ace. Okay, so that's how we do the odds for. So there are 2 black aces in the deck, which means there are 50 cards that are not a black ace. So notice that is different than the denominator of probability. Probability is how many do I have that I want over all the possibilities. Odds is listed as what is favorable and what is not favorable. So in other words, what is my event and what is not my event. So that's how you do odds 4. And then we can reduce that. That's 1 to 25. Now, again, they will probably make you, list your odds as a fraction as well in the My Math Lab homework. But honestly, most people prefer to not do that if we're doing it for like people to look at it and say, oh, that's an odds. So you should want to know that it's odds right away. So typically using the word to or the colon is more standard. Now let's look at the other one. It says a single card is drawn from a standard 52 card deck, calculate the probability and the odds for selecting a heart or a 7. Okay, so the probability, let's do that first, of a heart or a 7. Notice that's an or problem, so we should be doing probability of heart plus the probability that it's a 7 minus any probability that we double counted a heart and a 7. Okay, so hearts, there are, so I'll do this one in kind of magenta. We have 13 of those. And for 7s, we have 4. And notice we are over counting that 7 of hearts. So we'd have 13 out of 52 for the hearts, 4 out of 52 for the 7s, and minus that 1 7 of hearts that we double counted. So that is 17 minus 1, that's 16 over 52. If we reduce that by 4, that's going to be 4 out of 13. So that's the probability of selecting a heart or an ace. Now for the odds for heart or 7, you tell me how many hearts or 7s we have, and then we say how many not hearts or 7 do we have. Remember, it's favorable versus not favorable. So hearts are 7. So remember, that's kind of like this. It's actually this numerator before we reduce. There were 16 cards up here because we don't want to count the 7 twice that meet those criteria. So this would be 16 cards out of my deck are a heart or a 7. So remember, 52 minus that would tell me how many cards are not a heart or a 7. So 52 minus 16, that would be 36. That's the complement of that group. And then we do want to reduce that as well. So if I divide both of these by, looks like 4, that would be 4 to 9. So the odds in favor are 4 to 9. So if you had 13 cards in front of you, there's a, just because that's the total we get when we reduce this, it's likely that 4 of them will be a heart or a 7 and 9 would not, essentially. Now, if the probability of event A is 0.45, what are the odds for event A? Now, this one's a little bit different. So probability has been reduced to a decimal. What are the odds for the event A? So the odds for, a lot of how we structure this is in the 4. Notice you can turn that into a fraction that helps you see kind of how many cases you would have. So think about the easiest way. This is in the hundredths place. So when we turn that back into a fraction, that's like 45 over 100. That's what it was before we divided. Now, if you want to reduce that down, you can, or you can reduce it when you get down here. But essentially what that says is 45 things met my criteria out of 100 total items. So 100 minus the 45 is 55. So that means 55 items did not meet my criteria out of the 100. And when we go and reduce that, we can divide both of them by 5. So that'd be 9 to 11. So the odds for event A were 9 to 11. Okay, that is it for this video.